What if they were? What quiz means? It's generally speaking, a closed book. It's a closed book assessment with time pressure. I mean, generally speaking, but
Closed books?
well, not for you guys. All right. Well, I will begin with a word of prayer. Ahem. Hem. Hem. Dear Heavenly Father, we thank you for this day. I thank you for these students. Just ask you to help us to use this time wisely to glorify you what we do, Lord. In your name I pray, Lord Jesus. Amen. So you forgive me for partaking in some candy, but there's something wrong with me. I'm not sure what, but probably cold. Who knows? Let's see here. So let me work out these problems that I tried to get you guys to work. There will be a quiz next class, right? And here's the deal. So you have 2 more quizzes left. Are you guys done talking? So we have 3 days left, right? And then, of course, the final exam, right? And I can tell you when the final is, but I'd have to actually get my computer open. That sounds right.
Why on Friday?
Well, I think it's because you decided to take this class. It's on you.
I did.
If you really wanted to not have your final exam on Friday, then you should have planned ahead. The university, publishes a schedule. It's not my choice,
It was my choice.
It was Xavier. I didn't know you had such power, Xavier, but I'm intrigued. Let's see here. Well, if I could ever get out of here. So we have 3 classes left, I think. What's that? This class plus 2, that's right. Let's see here. So final exam, spring 23. This class meets when? 12:45, Tuesday, Thursday, right? So the schedule says that the final exam is 3:30 to 5:30 p.m. on
3:30 to 5:30 on a Friday.
That's what it says. 3:30 to 5:30 Friday. Cinco de Mayo. And on Cinco de Mayo, no less. Can I bring tacos? That seems like a lot of work. Yeah. What?
At Walmart, I saw a Batman pinata. What if I bought you that instead? Of the
A
quiz?
Batman pinata. That is interesting, but no, that's really nuts. If you, I just want correct solutions. That's if you want to like give me gifts, give me correct solutions. This is all I want. do the math. So guys, a few of you have asked me about your grade, right? And I'll try to make an announcement a little bit more about like ways of thinking about the grade. Please stop talking. So basically, I tallied it up. There's 420 points from quizzes, mission 1, 2, 3, right? And those points are what they are. Whatever you earn, you earn, all right? So if you only earned 200 points of those 420, then you're in trouble, right? Because you've lost 220 points of the 1,000 points, right? Which means that the highest grade you can earn in here is technically a C. Now, I mean, I will say such a person, if there was such a person, and if they made a 99.5% on their final with a cherry on top and all that good stuff, I'd probably still give them a B, because it would hurt me to not give a student who made a 99 on the final a grade of at least B. But on the other hand, I would think they really should have done their homework. Maybe I should give them a C just to teach them a lesson. So it's a struggle for me, you know? Do your homework. I know this is a little bit late to be telling you this, but not entirely too late because there still is mission 3, which is worth 100 points, right? So like, if you make 100 on mission 3, that's 100 points. Those I cannot take away from you. Those are yours to keep. Yeah.
Letter grades subjective?
Letter grades are subjective. Well, if you have over 900, then you have at least an A, right? But if you have under 900, then you're at my mercy. So, you know, being that I'm a petty vindictive, you know, person, and I've just been waiting for my chance to get back at you guys for all of the misery you've put me through this semester. It's in your best interest to have, by the letter of the law, the grade you want, right? I'm just joking, of course. This is the season of course evaluations. So,
Yeah, I could have filled it out before, but I think I'm going to wait to see how the rest of the class.
curses. So, I must give you my course evaluation spiel. So there's always this question about biblical integration. Like, does this course have integration of the biblical worldview or something like this? And I usually try to manipulate the statistics on this by asking you the following hypothetical. Do you believe that math is part of God's truth? Okay. Have we done math this semester? So if you say that biblical truth was not integrated in this class, you're saying that math is not part of God's truth. Do you want to be that person? No, you don't want to be that person. So do not vote not applicable, because it's not applicable. It's very applicable. Every class is applicable. Every class we're talking about God's truth. So it may be a little bit of a stretch. It may be a little bit of a stretch. Maybe it does, maybe it doesn't.
This is an easy interview right now. I think math is God's truth to the extent that all truth is God's truth. And so it's kind of an open door for anything that happens to be true.
Mm-hmm. Anyway, my point is that when I make this speech, all of a sudden my biblical integration score goes from like 20% to 70%. It's amazing how that works. It's almost like statistics are meaningless and really just are very sensitive to, you know, various subtle biasing of the questions. All right, anyway, joking aside, I will bring cookies Thursday, I think. So and that has nothing to do with course evaluations, of course. So I'm just saying that if I was on my game, I would have done it today before most of you had filled out the course evaluations, of course. Not that the cookies have anything to do with course evaluations. Not like we have seen, like I have seen multiple instructors who have learned that if they give cookies during course evaluations, their course evaluations improve. That, of course, is an absurdity. Why would that even be? Why would $10 worth of cookies make a difference?
You don't because we're broke college kids.
Oh. These will be homemade.
We don't need cookies as much as we need points. So I think we can work something out.
Well, yeah, I mean,
Is the term cookies code for decipoints?
no.
How many decipoints is a cookie worth?
How many decipoints is a cookie worth? I don't know.
All I'm saying is I need to get a grade, I need to get a course evaluation.
So, anyway, we have 3 classes left. I will try to solve as much of your homework with you as I can. So, like, at least one of you has questions about mission 3. That's good, right? So don't let yourself lose points on mission 3. Like, get them all correct. Get 100 points on that, and then those are points that you don't have to earn on the final. So the 420 points, right? Let's suppose that you did well. You earned 300 of these 420 points. All right. So you can figure out how many points that you have earned by looking at points you've lost, right? If I had a 60 on mission 1 and I had a 80 on mission 2, how many points did I lose? 40 from mission 1, 20 from mission 2, right? So I've lost 60 points there. If I've got, if I look at the sum total of my quiz grades and I got 80, I lost 40 points on quizzes, right? So in this hypothetical, I lost what? 100 points, right? Now, technically speaking, that means that you can't, well, you could barely earn an A if you made 100% on the final, right? But, I wouldn't rule out the A in that scenario. Just try to do your best. I do curve a little bit. I don't curve a lot, a little bit though. Anyway, I'll try to write announcements with a little bit more like systematic calculations so you guys can follow along better. I've worked it out for a couple of you who come to my office today. Ultimately, your grade rests on the final exam though, right? Because I will replace your test grade with your final exam grade if it's helpful, right? So, all right. With both tests. But I don't replace homework grades, I don't replace quiz grades. I only replace test grades. So
So if we got an A on the final, we would have an A on all 3 tests.
Test 1 or your lowest.
You would have an A on test 1 and 2, yeah.
That's crazy.
Wait,
Yeah, if we get 100 on the final, we get 100 on all 3 tests.
That's true.
200 points and not just one. It swaps for both.
Yeah,
That's wild.
I did say this before.
I thought you said
I thought it was only our lowest.
I only said 1. I mean, I did say that at one point.
I would have taken this 2 tests.
Well,
Because if we got 100 on both of those, we can follow the final and be okay.
well, I mean, I don't know. That's a good question. It's a good question. But the truth of the matter is, taking the test is one of the ways you guys learn the most. It's true. So, and also, if I said, welcome to college algebra, you're going to have a final exam which is worth 70% of your grade, you'd be like, ah, right? But now that you didn't do well on the test, you feel better about the final being worth 70% of your grade, right? Not that it's going to be 70% of your grade. It would be at most. What's 1,000 minus 420? 58% of the grade it could be. But listen, hopefully you did well on one of the tests already, and so hopefully I guess hopefully you'll do worse on the final so that test will still mean something. But I don't really hope that for you. I hope you do better on the final than you did on your tests. You know, that would be ideal. Listen, in practice, statistically speaking, how this works out, in a typical class, I don't see the whole grade of the class budge by more than about a half a grade. Like, because people don't usually do better on the final than they do on their tests. However, there are dramatic exceptions to that. On an individual level, there are students who will like bump up 2 test grades because they learned, right? And I do want to recognize that. If you learn the material and do better on the final, I would like to award you for that. So, all right, enough about that. How do we solve these? So this is log base 2, right? What's the natural enemy of log base 2? 2, yeah, exponentiate both sides base 2. So I'll write it like this. 2 to this equals 2 to that. So this gives us 3x minus 7 times x minus 4 is equal to 8. And at this point, we got to do the math. I mean, we got to multiply this thing out. We've got 3x squared minus 12x minus 7x plus 28 minus 8 equals to 0, which is 3x squared 19x plus 20. Oops, I don't know that. Equal to 0. This is an example from the book. It's like in the section 4.5, so it shouldn't be that nasty. This is probably going to factor, right? I'm guessing this is going to factor, so we won't actually need to complete the square. Ugh. Completing the square here would be unpleasant.
Minus 19 minus 1.
Minus 9, but I need to get 20.
It's a multiply. Negative 20 and negative.
Minus plus 20 minus 1.
But I don't think that's going to work because of 3. 4 and 5?
Yeah.
Minus 4 minus 5. So that gives you 3 times 5, which is 15, minus 15, and minus 4 minus 19. Yep. Yeah, I was originally thinking 20 and 1 as well because of the 19, but the thing that ruins that for us is the 3, right? That 3 is a pain. Anyway, so this gives us what? What are my solutions? I either get x equals to 4/3 or x equals to 5. And you can check that both of those work. If you go and plug those in, you'll get a positive value up here, I believe. So the 5 is just plus plus. If you plug in the 4/3, I think you get minus minus. Like this is 4 minus 7, which is minus 3, I think.
What would be 4 times 3?
This would be minus 3, and then this would be. Ugh. I don't know. What's that? What's 4/3 minus 4? It's 4 minus 12 over 3, right? Which is what you got? Minus 8 over 3. So when I plug 4/3 into this, I get minus 3 times minus 8 over 3 which is equal to 8. In other words, this going into the log base 2 evaluates to 8. Log base 2 of 8 is 3. It works. All right. Anyway, the larger point is that when I plug these numbers back in, I get positive input to the logarithm. Kind of a pain to check the answer here, but anyway. How about this one? So this one here, what we want to do is use the property of logarithms, right? Which is that this is the log of the product of 3x plus 2 by x minus 1. And that's equal to 1. Now when we have an unadorned log like this, what does that mean? This is a log base what? Log base 10 is our custom. So the natural enemy of log base 10 is raising both sides to the 10 power. So 10 to the this is equal to 10 to the that, which gives me 3x plus 2 times parentheses x minus 1 equals to 10. All right, well, plus what? Oh, no, not plus. This is important. So when we have log of A plus the log of B, then there's a rule that says that's the log of AB. This is a property of the logarithm that we're using. It does not maintain plus. Do not do that. That will make you lose half the credit. It's a bad mistake. Anyway, okay, so multiply it out. What do we got? We got ourselves 3x squared minus 3x plus 2x minus 2 minus 10 equal to 0. And this gives me a 3x squared minus x minus 12 equal to 0. And since I just copied this problem out of the book, I know that it has an ugly answer. We're going to use quadratic formula for a change of pace. What's the quadratic formula say? You're like, quadratic formula? No way. Yes way. Minus b, plus or minus the square root of b squared minus 4ac. Don't worry, I still love completing the square. In my heart, it's still there. But I'm gonna take a break for a second here. Quadratic formula. What is the a, the b, the c in play here? The b is minus 1, right? So we've got 1 plus or minus the square root of 1 squared, which is 1, minus 4 times a is 3 here, c is minus 12, all divided by 2a, which is in this case 6. So my solutions are 1 plus or minus the square root of, 145? Yeah, 145 over 6. Let's see here. Now, let me find out what those are, like decimal wise. Sure.
So, minus 36 times 4. Would it be 143?
Well, 12 times 12 is 144, right? Plus 1?
But it's 1 minus.
Oh, it's not.
No, but
Minus minus is plus. So I've got two minuses here. So 12 times 12 is 144. 144 plus 1 is 145. Now that works out to 2.562-ish or minus 1.562-ish. So if you think about putting those numbers back into the original problem, yep.
Oh, okay.
Which one do you think has to go?
Probably the negative one.
The negative one, why is that? Because if we plug the negative 1 into this guy, we've got minus 1.56 minus 1, which is minus 2.56, which means we'd be entering a negative number into a logarithm. To quote my community college professor, This dog, it will not hunt. Will not hunt. So we got to throw this one out as extraneous. It's not even in the solution set. So there we go. That one's dead to us. Answer is this guy right here, also known as 1 plus the square root of 145 over 6 if you want the exact answer there. All right, let me do another one, and then I'll answer the mission question here. Ooh, look at this, a log of a log. Now this one here is number 81. This is number 81 from section 4.5. All right. If you look at the course planner, I basically planned to be in section 4.5 until the end of class. This is pretty much what we're going to dwell on. All right. If you guys get really, really bored with this, we can go back and review previous tests. But I feel like, in my previous experience, this is the material you guys tend to like do bad on the final for, because this is the newest thing that you haven't quite gotten your system yet, right? And I don't want that to happen. So we do have 2 more quizzes. Hopefully that will help you assess your understanding of the material, right? There's no quiz today. I'm gonna give the quiz Thursday. Yeah.
So we're going to quiz on Thursday?
And Thursday and Tuesday. We have 2 more quizzes left, yeah. If you'd like, I could make one of them take home.
Yeah.
All right, so fine. For Thursday, I will make it a take-home quiz.
Mr. Cook, I love you so much. Mr. Cook is a friend of the people.
But in other words, I will post the take-home quiz later today. It will be due Thursday, start of class.
You're joking.
Why,
What a guy.
this has nothing to do with course evaluations happening this week. It's completely coincidental. Here. All right. Okay. So how do you solve a log? I was like under the log. I saw another log. It was a stick. Sorry. I think I've watched too much bad lip reading.
What's your favorite one?
Oof, I don't know. I like the one in the snow speeder.
Hostels on the
Yeah, Hostels on the Hill. I think that's my favorite. I think that would be the one. Yeah. Oh, okay. So the natural enemy of log base 2 is the 2 to the function, right? So exponentiate both sides base 2. What happens to that equation? If we raise, 2 to the this equals 2 to that, what happens? So this, I get this what comes out. This gives me log base 2 of x is equal to 2. All right? That's the first step. And then what do? Well, do it again. All right, so just exponentiate base 2 a second time. So if you take 2 logs, if you have 2 logs, one after the other, then to undo it, you need to exponentiate twice. So it's just do the same trick again. So this time 2 to the 2. Now this simplifies to x, and that gives me 4. There's your answer, 4. So that's actually not too bad, right? Okay, so what was your, now I finally made it back to your questions. Which one was it?
It's 89.
89.
I think it's 122.
So we'll start with 89. We're supposed to solve, so it's a symbolic problem, all right? I'll try to make up something similar but different. So this example is, it's in honor of problem 89, if you will. What? Do I got no juice? Where'd I put my juice? That's not my juice. But I guess I can use it. All right, hopefully it works. Ooh, such a nice sprayer. Is really good. My sprayer is like dead. Okay, so this problem 89, there's like letters A, B, and C, and it gives you instructions to solve for something. What does it say to solve for? For A. Okay, solve for A. So I'll make up something here, and we'll likewise solve for A. All right. So suppose we have something like 3 times log base, I'll do 7, of 2a minus b equals to, oh, I don't know, log base 7 of c. And then basically the instructions are solve for a. All right, so this is like example 4, which is kind of like problem 89 in your homework, all right? So how would you guys suggest I get started here? What do you want to do? Get rid of the what? Get rid of the log? How would I do that? Right, raise both sides to the 7 power. The problem with that is there's a 3. It's cramping my style. Divide both sides by 3 is a good idea. And I'll tell you why. If we brought that 3 inside as my opening move, that would be a bad idea, because then I would end up cubing 2a minus b. Cubing 2a minus b is not something we want to do if we can help it. If I bring 3 to the other side, that gives me 1/3 log base 7 of c. And how does that, well, that simplifies. It's a little bit ugly, but it's not too bad. See, this is log base 7 of c to the 1/3 power. That's another property of logarithm, right? There's 3 properties of logs that you must know about. The one is this one that I wrote up here. The other is the power property, namely that log of a to the power p is p times log of a. What was the third important property for log to know about? The log of a quotient, a over b, right, is the difference of log a and log b. So these are the 3 big rules for logarithms that we need to keep in mind. Of course, also the fact, like the other thing we've been using, of course, is like the inverse function, right? Log of the exponential is, it undoes, is, you know, the log of an exponent, their inverse is like, that's the other important thing, of course. All right, now that we did that, now we're ready. We have both sides are log base 7, right? So now that you have that, we can exponentiate both sides to the 7 power, right? Or you could just say by the 1-to-1 property, but anyway you slice it, we will get 2a minus b is equal to c to the 1/3 power. All right? I'm sorry, I seem to have written this calculation in this hideous Carolina blue. My apologies. Put that away. Ugh. Disgusting. Let's see here. So then 2a is equal to b plus c to the 1/3 power. And a is then equal to 1/2 b plus c to the 1/3 power. There you go. If I had gone down the unfortunate path of cubing 2a minus b, that would have made this problem much, much more difficult than it needs to be, right? In a similar vein, the problem you have in the homework has got a 2. I recommend putting that 2 to the other side. Yeah, if I divide by 2 rather than taking the bait and just putting 2 in, like if I put 2 in, then I'm squaring a minus b, which then is counter to my purposes of solving for a, you know? What was the other one you wanted me to? 124. All right. So, whoa. There's inequalities in here. What's up with that? Hey, you know what I did? There's a review for your final exam built into this homework, almost like I planned this. What do you know? Yeah, I think I might have done that. Let's see here. I'm going to read the following in course evaluations. Professor forgot that he put in plan for final and mission homework. Very disorganized. Let's see here.
Mr. Cook?
Yeah.
My mission got burned a little bit.
Your mission got burned a little bit?
Yeah. Just on the corners.
I mean,
That's fine. Just scroll down.
I think that's okay.
Okay.
I mean,
Because it caught on fire, silly question.
did I?
She
Did,
said how did it burn?
it's like a you're trying to. trying to make it look like a treasure map or something? I mean, this is like some kind of intentional, like, I'm gonna have to like read your solution in the moonlight so I can see the secret ink or whatever, or what's it gonna be? All right, so problem, what was it?
124.
124. Ooh, that's near the end, isn't it? So you're okay. So this problem is an interesting one because this combines a couple concepts. This is a combination of the graph concept and also systems of equations. So problem 124, you're given a polynomial that's quadratic, and you're told that the graph contains 3 points. So I'm not sure whether or not this is a pretty problem, like if it has nice answers or not, but I'll show you how to solve a similar problem that will almost certainly have ugly answers. So whether or not your problem is ugly, I'm not sure.
Problem view so that you don't have to look back and forth.
What's that?
I can read out the problem view so you don't have to look back and forth.
Okay. I got the paper right here. Let's see here. Oh, I see. Nice try. If it happens once, maybe it'll happen again.
I didn't even get full credit for the one that happened before.
Well, it's not my fault. Let's see here. Did I ever tell you guys about the pirate captain? At NC State, where I went to school before I was working here, there was this guy, he ran for student government. And the thing is, they never put in the student government charter that you had to run under your real name. So he ran as the pirate captain. Oh, he did.
Did he win?
Oh, he won by a lot. Because people were like,
I would so vote for
because basically it's like, this is a vote for mocking student government. Sign me up, right? And so he, oh, I'm sorry, are you guys in student government? No. My community college professor tried to get me to run for student government at the community college I went to start with. And I was like, no. If I was to be elected, my first act as president would be to absolve the student government and reduce student fees. Forever and ever, amen. Thank you. But that's the only action. I mean, if I can remove a sphere of government from my life, then I will do it. Good grief. Example.
I really think the SJ has very much power over us, like the actual government does.
Right. It's like an HOA. It's a stupid, unnecessary lay of government that it serves no one except themselves. Well, okay, the HOA serves the builder. It's basically them forcing you to keep your house nice so they can sell more houses.
So you can have all the same mailboxes.
Yeah. Oh yes. Very important to have the same mailboxes.
And then you can't have like
Otherwise, it'd be chaos.
maybe
So, all right. Sorry, guys. Ax squared plus bx plus c. This is the form that you're looking for, and we're given points. So find a, b, and c. Find a, b, and c such that the graph y equals f of x contains, I don't know, 0, 7, 1, 9, nice try, minus 1, 6, okay.
I get full credit for that by myself.
I mean, every one of you can get full credit on mission 3 by completing it.
Completing the square?
Well, there is probably completing the square in there.
Wait, mission 3 is completed?
What's that?
Mission 3 is a completion grade?
Well, if you don't complete it, you won't get a grade. That's true. Yeah. Let's see here.
So what if I just draw like a whole square on the paper?
Oh, I never did show you why it's called completing the square, did I? Let's see here. Okay, I'm getting distracted. You guys are bad influence. All right, so all we do, what does it mean for it to be on the graph? It means that when we plug the number in, it works, right? So f of 0 is 7, f of 1 is 9, f of minus 1 is 6. What does that mean? Well, we also can plug these numbers into the formula. So we have ax squared plus bx plus c, right? Plug in 0, what do you get? A times 0 squared plus b times 0 plus c, right? F of 1, we have a times 1 squared plus b times 1 plus c. F of minus 1, we have a times minus 1 squared plus b times minus 1 plus c. Let me work those out. Well, the top one's very nice. That's just c. The second one is a plus b plus c. The third one is a minus b. Now, I think the one you have in the mission, I have like 2 and a minus 2 for the x values, so you need to think more about that, right? Squaring 2 gives you 4, right? So you'll have like coefficients of 4 or 2 on the a or in the b, or you just have to evaluate the formula at the number that you're given and see what happens. Okay, so what are we up against? 3 equations, 3 unknowns, right? What are my equations? I have, I'll write the last one first. A minus b plus c equals to 6. I have a plus b plus c equals to 9. And I have c. I like this last, the first equation is actually very nice. C equals 7, so that's, all right, well, I guess c is 7 then, right? And so what's c equal to in your problem, problem 124? It's not 7. It's something else, though. If you look at what you're given, what did c equal to?
4.
4, right. So that actually makes this nicer, see, because while this in principle looks like 3 equations and 3 unknowns, because I told you, because we have c is equal to 7, we can plug that in, and the first 2 equations just become what? A minus b plus 7 equals to 6, and a plus b plus 7 equals to 9, right? Which then gives me what? This gives me a minus b is equal to minus 1, and a plus b is equal to 2. How should we solve those? Now, your homework isn't quite this nice because it's got 2 and minus 2 instead of 1 and minus 1, but it's kind of similar. So what I would do is I would add these equations, right? Remember that? So we add equations like so, and that gives me 2a is equal to 1. So therefore, a is equal to 1/2. And if we subtract the equations, what do we get? The a's cancel. We get minus 2b is equal to minus 3. Therefore, b is apparently equal to 3/2. So don't forget to make the conclusion for this kind of problem. What's the answer? F of x is apparently equal to 1/2 x squared plus 3/2 x plus 7 for me. And there you go. So this is one possibility for this kind of problem, but there's other versions of this problem which require you not to do algebra like this, but rather to use the theory that we've learned, right? So let me show you a different problem which looks the same but is actually totally different in substance. Like suppose example 6. What if I got, f of x equals to ax squared plus bx plus c such that 0 minus 1, 0, 3, not 0, 3, my bad. I'm doing this backwards. Minus 1, 0, 3, 0, and 10, 0. Oh, that's bad. I can't have that many. 10, 1. There we go. Are on graph. Now, this, admittedly, guys, we could solve this the same way I just solved example 5, all right? You could just plug in the numbers and you'd have 3 equations and 3 unknowns. But you shouldn't do that here. Why not? What's the easier way to solve this that we couldn't do over here? What's the difference between this problem and that problem? What's the difference? It's what?
We don't have to find A, B, and C.
Well, no, we still, I mean, I still want to, my bad, find ABC. Sorry. Yeah, I do mean to say that, find ABC. Okay, such that this holds. So look at the details. See the points that are given here? See that 0? Right? See this 0 here? Right? I didn't have that over here, right? If I was to plot this, those points are not particularly interesting. Here, what does this mean? This means if I was to graph it, right? -1, 0 and 3, 0, they're points on the x-axis, right? And roughly speaking, 10, 1 is, I don't know, it's here-ish, right? So what's the graph of this look like? It's something kind of sort of like that, you know? That's not the vertex necessarily, I'm just roughly. My point to you is the factor theorem applies here. See these guys right here? X plus 1 and x minus 3 are factors of f of x. What's that mean? That means that we can write f of x as a times x plus 1 times x minus 3. I don't know what a is, right? But I could figure that out because what's the other thing I have? I have that, you know, 10, 1 is on the graph, right? So what that tells me that f of 10 is equal to, well, that's equal to a times 11 times 10 minus 3, which is 7. And that's all equal to 1, right? So apparently, a is equal to 1 over 77. And so the answer, f of x, 1 over 77, x plus 1 times x minus 3. Now, well, that's not the answer yet, is it? Because what are you supposed to find? A, B, and C, right? How do we find A, B, and C? So you guys, what do we have to do? FOIL it, yeah, multiply it out, right? So this is 1 over 77, x squared plus x minus 3x minus 3, also known as 1 over 77, x squared minus 2 over 77, x minus 3 over 77. So now we've found a is equal to 1 over 77, b is minus 2 over 77, and c is minus 3 over 77. What does that mean? That means that if you were trying to solve this in the same method that we used for example 5, those equations would have been ugly, right? The solutions are 77ths. So it's important to know about the factor theorem and how to use it when it's appropriate, right? When is it not appropriate is when you don't have x-intercepts. If you don't have x-intercepts, you can't use the factor theorem, right? So, question? Yeah?
10, 1 be over 10 up 1.
Oh, what have I done? Oh, yeah. Yeah. So very wrong. Over 10 up 1. That's actually over here, isn't it? Yeah, my picture is like super wrong. Which means that, yeah. Okay, so this would have suggested the leading coefficient was negative. Was it? No, it was positive. What's that mean? It opens up, right? So the solution, thank you, excellent question. So it should look something more like this. This is not right, okay? But you get the general trend of things here, yeah? So, yes, sir. Other questions? Did you have other ones, or is that?
No.
That was it, huh? So I have actually built a review for your final into this mission 3, like the new material problems. They end where, you know, roughly speaking, well, problem 113, basically problem 113 and beyond, these are all review problems, all right? So, anyway, let's see here. See if I can find another one for us to work. Now, there are some, we haven't worked enough symbolic ones yet. Let's look at this problem. All right, so this is from section 4.5. It's like, I don't know, number 97. This is the formula for continuously compounded interest. The amount that you have in the bank is equal to the principal times 1 plus r over n. Actually, maybe this is not continuously compounded. What is this? Oh, this is, I think this is with n compounding periods. Anyway, whatever the stupid formula is. Not so important. The name of it times nt. All right? And then we're supposed to solve this for t. So how do you solve an equation like that for t? The relevance of this problem is if you had, you know, an investment where it was subject to this rule of amortization, and you knew the principal that you put in, you know the interest rate R that you have, and you want to know, and you know maybe it's compounded monthly, so like n might be 12, all right? Perhaps t is in years or something. You know, you want to know how long it takes to get your money to a certain amount. Well, then you could solve this equation for t. It would tell you how long it's going to take you for your investment to grow to that level. So that's the relevance of this algebra. How do you solve for t? What do you guys think we should do? Divide by p? Okay. I like it. A over p, 1 plus r over n to the nt. Now what should I do? Here's what I would do is I would take either the log or the natural log of both sides. It's up to you. What do you guys want to do, log or natural log? It's all good. Natural log it is, less writing. So natural log of a over p is equal to the natural log of 1 plus r over n to the nt. Now that's a nice move, because now I can look at this right here as a, and I can look at this right here as p, and I can think about this rule right here, right? So I can do the power property for the log, and this gives me equals to nt times the natural log of 1 plus r over n. And now we can just solve for t. So this gives me, you know, t is equal to the natural log of a over p divided by n times the natural log of 1 plus r over n. And that is it. Let's look at another one of these symbolic problems. Yes, sir.
So right there you divided the left side, like the natural log there, p by n times the. Why did I get rid of?
Oh, well, I just basically, I've got n times t times this, right? So I just divided by everything except for t. So I divided by this and all that to the other side.
And just left the other side.
Yeah, yeah.
Thank you.
Mm-hmm. Let's see here. Another one. Example. I don't know what example it is. I've lost track. 6, 7. I guess it's example 8. Y equals to big K divided by 1 plus a e to the minus bx. We're supposed to solve for b. So for what it's worth, this is problem 92 from section 4.5. Right? All right, so I want to solve for b. What should I do here? I think the first thing I want to do is multiply both sides by the denominator to like bring it out of the denominator. So, you know, this is y times 1 plus a e to the minus bx equals to k. That's a little bit better. I want to isolate the term with b, all right? So the next thing I'm going to do is multiply out what I have on the left-hand side. That gives me what? Y plus y a e to the minus bx equals to k. I'm getting closer. I'm trying to isolate b, right? And b is stuck in that exponential. I can't just ignore the exponential. I have to deal with it, right? Well, if I subtract y to the other side, that's a little bit better. I get what? Y a e to the minus bx is equal to k minus y. Okay. Better. Now, the next thing I'm going to do is I want to isolate that exponential. So if I divide both sides by ya, it's a little bit better. I have e to the minus bx is equal to k minus y divided by ya. Now, I'm trying to isolate b. How do I get it out of that exponential? What do I want to do now? Yes, exactly. This is what we should do. We should take the natural log of both sides. That is, in fact, the secret sauce. Now, the thing is, you got to know when to do it, right? If I'd just taken the natural log willy-nilly to start with here, just because I saw an exponential, it would have got me nowhere, right? If I had taken the natural log back up here, it does me no good. So sometimes you have to do a little bit of preparatory work before you can actually use the inverse function. But now we've done that, so like you said, take the natural log of both sides. The natural log of e to the minus bx is the natural log of k minus y over ya. All right. Now, so we get minus bx is equal to the natural log of k minus y over ya. And then finally, finishing move, x equals to minus 1 over b, natural log of the quotient of big K minus y over ya. Oh man. Trade that x and b. There we go. Sorry. Thank you. Obviously, we could have also solved for x if you wanted. Hey, if I'd solved for x, what would this have been?
X equals negative 1 over b.
Okay. And what would that what would that have meant? The inverse function. That's right. That would have been the inverse function in this case. See, in other words, if this guy up here is f of x, right? If that's equal to f of x, then this would be f inverse of y. Hey, well, you know, that's a twofer. I gotta tell I sure hope my wife is up for making all these cookies. But you probably should just do the evaluation and the assumption, not that it matters, that there's going to be cookies. What's that? It's before finals. I think it may be like, I don't have to, I may be, I'm not sure when it ends. Sometime, somewhat soon. Uh-huh. I'm gonna send it to you guys today. Yeah. I just need to go write it. It shouldn't take super long. Yeah.